Welcome to this lecture on Microcontroller 8051. We are actually moving towards the programming concepts, and before we move to the programming concepts, we will discuss the addressing modes of 8051. So let us start. These are 10 addressing modes for 8051: immediate addressing, register addressing, direct addressing, indirect addressing, relative addressing, absolute addressing, long addressing, indexed addressing, bit inherent addressing, bit direct addressing. So let's take them one by one. Immediate addressing is a sort of addressing in which the direct data is given inside the instruction to be moved to a particular register. The hashtag is the indicator for such addressing. We have the instructions like move a #45h, means that the 45 is the hexadecimal data that is to be moved to the accumulator A. Add a #7ch, accumulator to be added with immediate data 7ch. So hash is the indication of immediate data. In the register addressing, the register will be taken as the data source. So there are 8 registers in a particular bank, and default bank is bank 0. Means whenever we address registers from R0 to R7, we have the bank 0 of these registers available. If we want to move to some other bank, then we have to indicate it that we are moving to another bank. But default, if you use registers, it will be taken as the 0 bank. Move a R3 means the data in the register R3 will be moved to accumulator. Add a R5. R5 data will be added to the data of the accumulator. In the direct addressing, the address of the memory where the data is present is indicated inside the instruction. Suppose we have move a 40h. The data in the 40h memory of the microcontroller will be transferred to A. In the same way, if we have add a 3bh, means the location 3bh data will be added to the contents of the accumulator. There's difference between now the 40h and #40h. Hash 40H will be taken direct data, immediate data, and 40H will be taken as the memory. And the memory ranges from 00H to FFH. In the indirect addressing, we have these registers being used as addresses. So the a register to hold the address that will be used in the data movement. Again, the same registers R0 and R1 and DPTR are the three registers which are used for such type of indirect addressing. Because we have move A at the rate R0, that means the address indicated by R0 memory is to be moved to the accumulator. And this, in the same way, we have add A at the rate R1, means the R1 will be taken as the pointer. It will point towards a memory, and that memory data will be added to the contents of accumulator. In the same way, we have the data pointer DPTR as the address, but that DPTR is holding 16 bit of address. So in that, the data pointer is used as a pointer to move the data from memory to a particular register, here A, the accumulator. In the indexed addressing, we use the DPTR or program counter. In addition to the accumulator contents itself, to move the data from memory to the accumulator. This sort of addressing is known as indexed addressing. The next is relative addressing. The relative addressing is used only with the conditional jump instructions. The relative address or offset, what we call as, is an 8-bit signed number which is actually added to the program counter. The number will be in the accumulator, it will be added to the program counter. And since it is signed, so we can have the numbers between 127 to minus 128 locations. The jump destination is usually specified using a label, and the assembler calculates the jump offset as it to jump up or down according to the indicative contents. Address contents. So such jumps like S jump loop 1 or JC back. So in this way that the jump can move forward or backward in the with the help of the offset. Now we have the absolute addressing. In the absolute addressing, we have absolute jumps or absolute call. They are used for such type of instructions, and you see that there is a jump loop and a call loop. A call loop and a jump loop are the instructions, and when we use them, that means this absolute call, this inside the inside memory, 2k byte program memory. So what is that? The absolute addressing mode specifies the lowest 11 bits of the memory as part of the instruction. The upper 5 bits of the destination address or the program counter 5 bits, upper 5 bits. Hence this absolute addressing allows branching only within that internal memory. The long addressing is always for the external memory, what we call as the 64 kilobyte memory that can be connected to a microcontroller from outside. So in that we have the L jump, means long jump, means you have to jump again to the external memory, which can be of the order of 64 kilobytes, or A call delay means L call delay means that the call will take place to the outside memory of a particular location indicated by delay. Bit inherent addressing is like we are handling the bits. So such type of addressing to bits. Suppose we have some bits used as flags, so we can use clear a flag or clear a bit. So you can say clear C means will clear the carry flag. And in there we can have clear 0, Z clear Z means it will clear the Z flag, 0 flag. Then we have the bit direct addressing. We know that there are 4 ports, 8-bit ports available in a microcontroller 8051. So those all 4 ports will make 32 bits, individual bits, and those individual bits can be programmed individually as a single bit. So every bit has a number. If we give a number of the bit, that means a particular bit will be set or reset. So that's called a bit direct addressing. In this we have the clear 07H, indicating that the 7th bit is to be cleared, is to be reset or cleared. In the same way we have set B07H, means it will set the bit 7 of 2H memory, which is kept for 2H memory. 20H memory is kept for 20H memory. Actually means the 32 bits, because it is 2 into 16 raised power 1. That means it is addressing all bits one by one. There are 32 locations kept and 32 locations actually select bits one by one. So this is all about this addressing modes of 8051. With this we come to the end of this lecture. Thank you very much.